Hello everyone, welcome to CHE Education's channel. Today, we're diving into the world of chemical engineering software. In this video, we'll go over the essential software tools that every chemical engineer should learn. We're talking about the programs that help us design, simulate, and optimize everything from the tiniest molecule to massive industrial plants. Whether you're a student, a recent graduate, or already working in the industry, this video is for you if you want to learn software but aren't sure where to start. We'll cover the heavy hitters, the fan favorites, and even a few hidden gems that you might not have heard of before. So buckle up, grab your safety goggles, and let's get this software party started. First up, we've got the OG of spreadsheets, Microsoft Excel. Now I know what you're thinking. Excel? Isn't that like for accountants and making grocery lists? And yeah, it can totally handle that stuff. But don't let its humble appearance fool you. Excel is a powerhouse for chemical engineers. Need to crunch numbers from an experiment? Excel can handle it. Want to create graphs and charts that would make your data sing? Excel's got you covered. From process calculations to creating those super handy one-point lessons, Excel's applications are about as diverse as the chemicals we work with. One of the coolest things about Excel is its ability to organize and analyze data. Imagine you're working in a plant, and you've got sensors spitting out readings every second, temperatures, pressures, flow rates, the whole shebang. Excel can take that mountain of data and turn it into something meaningful. You can track trends, identify anomalies, and basically become a data detective. All thanks to the magic of spreadsheets. But wait, there's more. Excel is also a champ when it comes to plant design. Remember those block flow diagrams, BFDs, and process flow diagrams, PFDs, you learned about in school? Yeah, those bad boys can be whipped up in Excel faster than you can say stoichiometry. And the best part? Excel is pretty much everywhere. Don't underestimate the power of a well-formatted spreadsheet. Alright, let's talk blueprints, baby. And no, I'm not talking about some dusty old scrolls you find in an attic. I'm talking about AutoCAD, the software that lets you design and visualize the chemical plants of tomorrow. Imagine you could walk through a chemical plant before a single brick is laid, tracing the path of reactions from giant reactors to towering distillation columns. That's the power of AutoCAD. It's like having X-ray vision for engineers, allowing you to see through walls, floors, and even time itself to peer into the heart of a chemical process. But AutoCAD isn't just about pretty pictures. Sure, the 3D models look super slick, but they're also packed with information. Every pipe, every valve, every sensor is meticulously laid out, creating a digital twin of the real deal. This level of detail is crucial for catching potential problems before they even happen. Imagine spotting a design flaw that could have caused a major shutdown, all thanks to some clever clicks and drags in AutoCAD. AutoCAD is surprisingly user-friendly, even if you're more comfortable with a beaker than a paintbrush. Trust me, once you start bringing your chemical engineering visions to life in AutoCAD, you'll be hooked. Okay folks, it's time to level up our chemical engineering game and dive into the world of MATLAB and Simulink. Now I'm not gonna lie, these programs are a bit more hardcore than Excel or AutoCAD. But trust me, the learning curve is worth it, because MATLAB and Simulink give you the power to simulate and analyze complex chemical processes like never before. Think of MATLAB as the ultimate chemical engineering calculator. It can handle everything from basic algebra to mind-bending differential equations. But here's where things get really interesting. Simulink. Imagine being able to build a virtual model of an entire chemical plant, complete with reactors, distillation columns, heat exchangers, the whole shebang. That's what Simulink lets you do. You can connect different components, tweak parameters, and watch how the entire system behaves without risking a single drop of hazardous chemicals. This kind of simulation power is an absolute game changer for chemical engineers. The skills you learn here will be valuable pretty much anywhere you go. Chapter 4. Aspen HiSYS, the industry heavyweight. Alright folks, it's time to bring out the big guns. If you're serious about a career in chemical engineering, especially in industries like oil and gas or petrochemicals, then you need to get familiar with Aspen HiSYS. This software is the gold standard for process simulation and optimization, used by companies all over the world to design and operate some of the most complex chemical plants imaginable. Think of HiSYS as the ultimate chemical engineering playground. It's got everything you need to model, simulate, and analyze even the most intricate processes. Want to design a refinery that can turn crude oil into gasoline, diesel, and jet fuel? HiSYS can handle it. Need to optimize a distillation column to separate a complex mixture of chemicals? HiSYS has got your back. It's like having a team of chemical engineering geniuses at your fingertips, ready to help you solve even the toughest challenges. Now, HiSYS does come with a bit of a learning curve. But hey, good things take time, right? And trust me, the time you invest in learning HiSYS will pay off big time in your career. Embrace the challenge, dive in headfirst, and get ready to unlock a whole new level of chemical engineering awesomeness. Chapter 5. DWSIM, Open Source Powerhouse. Now, let's talk about DWSIM, the open source hero of the chemical engineering software world. You see, not everyone has access to expensive software licenses, especially students or folks just starting out their careers. That's where DWSIM comes in, offering a powerful and completely free alternative to commercial options like Aspen HiSYS. Don't let the free tag fool you though. DWSIM is no slouch when it comes to features. It's got all the essentials you need to model, simulate, and analyze a wide range of chemical processes. From basic thermodynamics to complex reaction kinetics, DWSIM can handle it all without breaking a sweat or your bank account. One of the coolest things about DWSIM is its flexibility. Being open source means that anyone can contribute to its development, adding new features, fixing bugs, and generally making it even more awesome. Whether you're a student working on a design project or a researcher exploring new chemical processes, DWSIM is definitely worth checking out. Chapter 6. CAM/CAD, Bridging the Gap Between Design and Reality. Alright, imagine this. You've designed the most amazing chemical plant ever, complete with gleaming reactors, perfectly optimized distillation columns, and enough piping to make a plumber weep with joy. But here's the catch. How do you actually build this thing? That's where CAM/CAD comes in, bridging the gap between the digital world of design and the real-world challenges of construction and manufacturing. Think of CAM/CAD as the language translator between your computer and the machines that actually build stuff. It takes your fancy three-dimensional models and converts them into detailed instructions that robots and CNC machines can understand. This process, known as computer-aided manufacturing, or CAM, is what allows us to turn digital dreams into physical realities. But CAM/CAD is more than just a translator. It's also a powerful tool for optimizing your designs for manufacturability. Remember all those intricate details you painstakingly modeled in AutoCAD? Well, CAM/CAD can help ensure that those details can actually be manufactured efficiently and cost-effectively. When it comes to bringing your chemical engineering creations to life, CAM/CAD is an absolute essential. That wraps up our list of essential software for chemical engineers. We've covered a lot of ground today, from the humble spreadsheet to the mighty Aspen HiSYS. Remember, the best software is the one that helps you solve problems and achieve your goals. So don't be afraid to experiment, explore different options, and find the tools that work best for you. Let me know in the comments which software you're most excited to learn, And if you've got any favorite chemical engineering software that I didn't mention, share those too. Thank you for watching, and stay tuned for more in-depth tutorials on each of these tools. Until next time, stay curious, stay safe, and keep on engineering.